of d of x over square root of 1 minus x squared. So this one, it will give you, it can either be arc sine of x or minus arc cosine of x plus c plus c. But most of the time I would advise you to be going with this. Normally this makes more sense. Okay, this is the equation for arc cosine, but the general formula also for this one is something like if you have this d of x over integral of a squared minus x squared, this will be equal to arc sine of x over a plus c. You have another equation like integral of d of x over square root of x squared plus 1. This is equal to, okay, so in as much as if you don't pay attention, you might be tempted to think that this is the same as arctangent, but no, the difference is with the square root. So when you see this type of equation, your final answer will be ln of, so this, the value of the x here will be x plus, then you get what is here, somewhere there, x squared plus 1 of this plus c. This is the answer. The general formula for this equation, the formula is if you have integral of d of x of square root of x squared plus a squared, this ln of x plus square root x squared plus a squared plus c. This is the general formula. So depending what your a is, you can substitute it there. If you have integral of d of x over square root of b, it can be written as x squared minus 1. Okay, in as much as this is very tempting for you, remove negative 1 so that this looks like arc sine. That one will give you with an imaginary, which is arc sine imaginary. That is more complicated. So better you just deal with this directly, which will give you as your answer will be ln of x plus square root x squared minus 1 x. Then the general formula, just remember, d of x over square root of x squared minus a squared. This will be equal to ln of x plus square root x squared minus a squared plus c. Okay, if you have integral of d of x, and instead of you having x to the power 2, you just have a linear function down there. So you have something, it can be x or x minus 1. This will be equal to 2 over 1 square root of x minus 1 plus c. So general formula is integral of d of x over some linear function which is ax plus b. This will be equal to 2 over a square root of ax plus b plus c. If you have integral of square root of ax plus b with respect to d of x, this will be equal to 2 over 3a a plus x plus b bracket to the power 3 over 2 plus c. If you have an integral of a to the power x, the d of x. So for this one, the answer is equals to a to the power of x over ln of a plus c. That's the general formula. However, we have a condition on this one, and the condition is a should be greater than 0 and our a should not be equal to 1. The reason why a should not be equal to 1 because ln of 1 will give us 0 and this will be undefined. So a should not be equal to 1 and a should always be greater than 0. Integral of e to the power of x with respect to d of x. This one doesn't change, it's always the same, plus